So this question says the expression 4x squared plus bx minus 45, where b is a constant, can be rewritten as this: product of binomials, hx plus k times x plus j, where h, k, and j are integer constants. Which of the following must be an integer? All right, so because I know that this can be rewritten as this, I'm actually going to set those two things equal to each other down here. So I'm going to say 4x squared plus bx minus 45 is equal to hx plus k times x plus j. And then I'm going to simplify this right-hand side by using FOIL. So FOIL, the F stands for multiplying the two first terms, so that becomes a hx squared. The O is multiplying the two outer terms, so that becomes a plus hxj. The I represents multiplying the two inner terms, that becomes a kx, so plus kx. And the L is for multiplying the two last terms, which is k times j. That becomes plus kj. And of course, this is still all equal to 4x squared plus bx minus 45. All right, so what does this help me to know? This helps me to know, actually, that this hx squared here is equal to 4x squared. Right? Those are the only x squared terms on both sides. So I'm going to write that down. 4x squared equals hx squared. And by default, that tells me that h must be equal to 4. Right? That's the only way that that becomes a true statement. Now let's look at the x terms. I have this bx, and I have this hxj, and this kx. So bx must be equal to, and I'm going to write this slightly differently, hjx plus kx. I'm actually going to simplify this a bit and pull the x out and call this x times hj plus k. And what does that tell me? That tells me that b is equal to the hj plus k portion. I know that h is 4, by the way, so that tells me that b is equal to 4j plus k. All right, just trying to simplify this as much as I possibly can. And again, just to make sure we got it, this x matches with this x. Therefore, this stuff in here is what goes with the b. That's why I matched that together. Lastly, I have this negative 45 is equal to kj. Excuse me. Equal to kj. I don't know what k or j is, so there we go. So k times j in some way has to multiply to equal negative 45. So which of the following must be an integer? Let's see. So b over h. Well, I know h is 4. I know that b is 4j plus k. Can I say for sure that that has to be an integer? I don't think so, but I'll come back to it. For choice B, again, I know that b is 4j plus k. I know that I don't know what k is, so I just have k. I don't know that that has to be an integer either. C, I have 45 over h, which is 4. That's definitely not an integer, so that's helpful. I can cross that out. And D, I have 45 over k, which again, okay, so that's interesting. So I have 45 over k here, but I also know that negative 45 is equal to kj. So I know that k times j is negative 45. That means that k has to be a factor of 45. Let's just think about that, right? So how could this work out? This could be like a negative 9 times 5. It could be a negative 5 times 9, of course. It could be a negative 45 times 1. It could be a 1 times negative 45. So we're told that these are all integers, by the way. So that's why I can say that. So then these are really the only options I have. And either one of those scenarios, whether k is equal to negative 9, negative 5, positive 9, 45, or negative 45, or 1, or it doesn't matter which one of those things it is. and we know that it has to be one of them, any one of those things will make this become an integer. So choice D is the best answer. Hopefully that makes sense. Hopefully that makes sense. There may have been a faster way to get there now that I'm looking at it, but I'm glad that I did the video this way because it just explains exactly how to break this stuff down, how to connect these two things together, and how to connect each part, right? The 4x squared to the hx squared, the bx to this middle term here, the negative 45 to the kj. They all match up together.